Hi, in this video, I'm going to share with you 7 tips that you can use in the drawing mode of Solidworks that can help your work to be much more efficient, and you will thank me later. So let's watch. Hi, I'm Aryan, and I help engineers and creative minds to bring their ideas into reality through learning Solidworks with a very easy approach. So if this is something for you, consider subscribing. Let's get started. Okay, so let's get to the point. I have the drawing ready. I'm gonna cover 7 useful tips for you. Tip number 1 would be how to add tolerance to your dimensions. Look, we have a dimension over here that is 11, sure, but it doesn't show or have any tolerances. What if you want to add a tolerance to it? Like this one, which is 0 by 0. It's easy. You just one time click on that dimension. One left click of your mouse is enough, and then you get the property manager of your dimension. Or you could just click on it, and before moving your mouse cursor, you see this pop-up appear, and when you move your mouse on it, this box opens where you can first define the type of tolerance that you want to assign to it. We have basic tolerance, that is no tolerance at all. We have the bilateral, that is plus this value minus this value, and if your values are equal, you could go for symmetric, plus minus this value. And when I say this value, you could just type any value you want. So that would be 11 plus minus 0.5. Or if you want to go bilateral, you could do minus 0.2 plus 0.5. You could also do a limit. What does that mean? When you do a limit, you get 2 dimensions, that is the minimum dimension and the maximum dimension acceptable. That all depends on your manufacturer and who you're working with, what system you're working in, and so on and so forth. So this is the type of tolerance that you can assign. We have min and max, and we have 3 type of fit: fit with tolerance, normal fit, and I think force fit. These are for pins, but I'm not gonna cover them at all in this video. They have their own category and they need a separate video. So let's stick to the bilateral, limit, and symmetric. And over here in the next tab, you can define the number of digits that your tolerance should be in. So currently I have 2, which is based on my document. As you can see, I can increase it. Then I have the 3rd digit after the comma or the decimal points, or I can just increase it more and less. All right, this is also for my main dimension. It has 3. I can add it to 2, and since it follows the document, it can also be in 2. It doesn't make sense to have your dimension with more digits and your tolerance with less digits. Okay, before I move on to the next tip, one bonus: this is an inspection slot that you can put around your dimensions. That is, when you order your component and your components arrive at your facility and you do have to perform an incoming good inspections or IGI, you could mark the dimensions that are important for you or the quality control department to measure. So you put that around it. Tip number 2 is very useful. As you can see, let me just go to the component. I have used Hole Wizard to add 3 points over here, 3 holes actually. I could definitely use my smart dimension and add the values I want, and then type whatever I want to type next to it. For example, I have 3 of these. I could just press it here, open that box, and then type 3x this. It means I have 3 of these. 1, 2, 3. Sure, I can write above it, I can write below it. Everything is possible. You could do that, but instead of wasting your time and just typing numerical values, you could actually go to the annotations tab over here and pick hole callout. When you do that and you click on your hole, it gives you all the value that you need at once. You could press it here. I have already done it on this hole, and it gives all the necessary information that the manufacturer needs. So we have 3 holes. First of all, the inner diameter is 3.4, the depth is 21, and the outer chamfered value at the 90 degrees chamfered is 6.3 in diameter. That is this bigger circle. So hole callout, where is it, would give you all of that you need. I just click anywhere and then readjust its position like that. So this is very useful if you're working with Whole Wizard and you want to later address it in the drawing. The third tip is actually super easy and basic, but since I've seen and heard a lot of questions from you guys, I'm gonna add it to these 7 tips, and that is how to change the scale of your model on the sheet, because your model is currently following the dimensions of the sheet. And when I click on that, you can see it. Click on your model and you can see it's using the sheet scale. However, I can change it to whatever I want manually, use custom scale and make it, I don't know, 1:1. That would be okay. But let's just say we want to go ahead and only change the sheet scale, not an individual view of this component. And for that, I can find the sheet right here, right click on that and go to its properties. This is the scale. You can change it here and it will adjust. Sometimes in SolidWorks, you're gonna have to work with out of proportion components like this one. For example, I'm in an industry that we work with catheters with the diameter of maybe up to 2 or 3 millimeters. That is like how many inches? You can see it on your screen. And the length goes up to 2 meters. So it's way out of proportion. And when we want to create a drawing out of this out of proportion component, if I bring that component here, first of all, yes, I can reduce the scale, or SolidWorks reduces the scale as much as necessary until it fits onto your drawing. But if I'm going to address its diameter, something like this, or even the inner diameter, it's so small that nobody can see anything. So of course, I can go and scale up my sheet just like I showed you. It's 1:100. Let's just say I want to bring it 1:1. And then when I do that, the length of my component exceeds the length of my sheet. So what do I do in this case? Well, we have this break view, which allows you to just cut your component as much as necessary. Look at that. This is the symbol for it. And you see that the component is shortened in view, not in actual dimensions. Now, if I'm going to add the diameter, you can see the value very clearly. Okay, it's 0.04, and the length is actually 10, which was, what were the units? Let me change the units. It's not 10, it should be 1,000. Right, you can see that it's 10,000 millimeters or 10 meters, and the diameter is 36. Even though it's out of proportion, by reducing the length using the break view and increasing my scale of the sheet, I can actually see the whole thing in the sheet as well as all the small details. Even though, for example, I can also add the inner diameter. And even though it's the smallest dimension I can get from this component, it is pretty clear what this 24.44 is assigned it to. So you can use that, and also you can drag this break view in either way, either left or right, to make it bigger or smaller. If I take the left side, move it to the right, it makes it longer. Or take the right side, move it to the left, again it makes it longer. But right to the right, left to the left makes it shorter, just because if we are creating a bigger gap, then it would just move again together and they shrink. So that was a break view, and the sign for that is this broken symbol on your dimension. It shows this dimension is actually 10,000, but it is not the actual 10,000 that you're looking at, it's shrunk. Now, going back to my actual drawing, when I zoom on this component, you see a lot of hidden lines and a lot of details, especially in this area. And if I'm going to add some dimensions to it, not only it would make it super messy, you will probably don't understand what's what. So for that, I'm gonna cover view detail, which you can find on the drawing tab over here. It's really easy. You first select a center for your circle. I say circle because after that it will turn into a circle, and whatever you put inside that circle will be magnified and you can add it somewhere else. Before I click, I make sure I like to get the same scale as I want, 2:1, and then I add it here. Look, this is detail C, scale 2:1, and this is C. And if you want your C to be like B with a leader, you could just change that with leader then move it here. So this is detail B, and you can see detail B 221 here, and this is detail C. You can also add dimensions in the zoomed detail view so you don't make your drawing super messy. That was the detail view. Now, if I add anything or change anything in this main component, this happens here. This is like a magnifying glass over the circle C. If I reduce the circle, I get less amount of details, and if I increase it, I get more amount of details. You can see that, right? And if you don't know what's happening, I can just click on my view and make a full outline so you know what's what. No outline, full outline, and you can see it. This is the circle. Whatever goes inside the circle happens there, and whatever doesn't, you don't see it there. Well, the next tip is kind of like a cheating. It could be used in a lot of situations, but make sure not to abuse this, because especially if you're a beginner and if you learn this trick, you might start building bad habits over using this. This is only for cases where, well, I'm not gonna say for what cases, but you'll know when you need it. And this is overriding a value, because in SolidWorks, your smart dimension is not lying to you. When it says the distance, the horizontal distance from these 2 points is 60.84, it is 60.84. And if I want to change that, I'm gonna have to go ahead, open the model, and actually change the model, come back here and get my actualized or new dimension. However, there is a way to override that, and that is why one time clicking on it, going to property manager of my dimension, and then click on overwrite value and type, I don't know, 70, and then leave it at that, or 709. It doesn't change anything. Look, it doesn't make any sense, because the whole distance from here to here is 120, and how can this be 709? But you can. Mostly I use that for parametric drawing, that is designing exams. I'm gonna say this value is A, and then I'm gonna say this value is B. Then I can create a table over here with different values for A and B. For example, I could go to annotations, table, just the general table would be fine. 2 by 2 is fine as well. I'm gonna put it here, just drag it. Let's say A, and then we have B, and then it's, I don't know, 20 and 30, or actually let's just add insert to the right and insert above, right, size small, size big, and we do 30 and we do 40. So this is how I would do if I'm going to create something parametric, and this component comes in different sizes. Instead of creating different drawings for every single size, I will add dimensions, then I will override them with letters, making them parametric. Then I will add a table for the size S, M, L, whatever you want to call it, and then you add the values for your ABC and so on and so forth. So this is a very good tip to save time and not duplicate so many unnecessary drawings. Okay, the last tip I want to include in this video is auto dimensioning, and it works only if you have already assigned actual dimensions to your model when you model the 3D part. You cannot just don't do anything when you're modeling in 3D and then come back in drawing expecting SolidWorks to add the dimensions that you want automatically to it. It doesn't work like that. You go to the annotations tab, then you don't go to the smart dimension. Counterintuitively, you go to model items, and then you select entire model, that is whatever you have here. Then you can select what you want SolidWorks to assign to your drawing. You could select it all depending on what you have used. Just take a look. If not, you can uncheck them, that's fine, and then you click OK. Look, it doesn't come super clean, but at least I can sort it out really quick. And this is the radius, this is the distance. Then there are some situations like this one that some of the dimensions don't make any sense. I'm not talking about the double O's, because the double O's are here because I'm working with ISO while my dimensionings were in ANSI. Now it's fixed. Look at that. What doesn't make sense is this 20, because when I created this component, apparently I have set a distance from this edge to another component that is not present in my drawing. So SolidWorks assigns that dimension as well, but it doesn't make any sense. So manually, I will delete this one. Again, similarly, if you don't get a value that you should be getting, you could just manually add it. That's fine too. That was the tip. That was tip number 7. Let me know if you liked this video in the comment section below. If you did, I can add another 7 tips that I know that are still new. There are many tips that I know you don't know in the drawing mode of SolidWorks. And if you like it, I can cover more of those. That's that. Also, do not forget to go in the comment section below or in the description below this video, click on the link, go to my website and watch my webinar. What webinar is that and why I say you should watch it? It's a 1-hour webinar where I cover 10 of the most common mistakes that I see every SolidWorks beginner and self-taught users are making. And I will replace that with good habits right there and then for you once and for all. Then you can start saving 90% of your modeling time, which after the webinar, you know you have been wasting. So that's where the why and the how is in the link in the description below or on the top right corner of the screen if this is the top right corner. If not, just put a buzz on the video. I don't know. I hope it is. Anyways, do not forget to check the webinar. It helps you, and at the end of the webinar, I will grant you an access to my mini course, all of which for free. Subscribe and I'll see you next week.